all of the logarithms that we've looked at to this point were able to be figured out by just using your algebraic knowledge. But as we get further into logarithms, we need to be able to solve for logs that aren't quite as easy without just doing guess and check. So our first method, we're going to start off with an approximate value for one of the logs that we're going to need. So for instance, I'm going to tell you that log 23 is approximately equal to 1.5850. So this says 2 to what power gives me 3. So if I take 2 to the 1.5850 approximately, I will get an answer of 3. So I'm going to use that information as we try to solve for A, B, C, and D. Now for A, we may or may not need to use that given information. So for instance, I have a log 2 to what power gives me 4. Well, I know without using log 23 that 2 to the second power is equal to 4. So log 24 is equal to 2. So 2 to what power gives me 4? The answer is 2. Now for part B, that one's a little bit different. So I have log 26. 2 to what power gives me 6? Well, that doesn't come out evenly. So I'm going to have to use some given information. Well, I can use any log that I know the answer to. So for instance, I know log 2 of 3 because it's given right here. I also know log 2 of 2. So log 2 of 2. So 2 to what power gives me 2? Well, I know the answer is equal to 1 because 2 to the first gives me 2. So I'm going to break apart log 26. So log 26 is the same thing as log 2, 3 times 2. Now, if you remember your properties of exponents, when you multiply things together, you add the exponents. So this is kind of the same thing. So we have a multiplication problem, and to break that log apart into two separate logs, we're going to go backwards. So it's a multiplication of two different numbers, so we're going to go backwards and create an addition problem. So I have log 2, 3 plus log 2, 2, because you got to remember when we're dealing with logs, we're dealing with exponents. So I have multiplication, and we're going to take that number and we're going to add it together like you would add two exponents. So now I have log 2, 3. We know log 2, 3 is equal to 1.5850. And I know log 2, 2 is equal to 1. So I add those two numbers together, I get 2.5850. Okay, so log 2, 6 is equal to 2.5850. So multiplication and addition go together. So if I want to break a log apart that's being multiplied, I'm going to use addition to make that happen. Now if I look at part C, instead of multiplication, now I have division. So to break that log apart, I'm going to use subtraction since we have division. So I have log 2, 4 minus log 2, 2. And again, I have to look at each log and see if I can solve them. So the first one, 2 to the what power gives me 4? Well, I know 2 squared is equal to 4, so that one's equal to 2. Minus log 2, 2. 2 to what power gives me 2? Well, I know 2 to the first gives me 2. 2 minus 1 is 1. So log 2, 4 divided by 2 is equal to 1. You could have also just taken 4 divided by 2 and got 2, and log 2 of 2 is equal to 1. Now the last one, we have log 2, 9. Again, I can't take 2 to a power and get to 9, so I'm going to try to bust 9 up into factors. And I know log 2, 3, so I'm going to break 9 up into log 2, 3 times 3. And since we have multiplication, we're going to separate that log with addition. So log 2, 3 plus log 2, 3. Okay, and I know what log 2, 3 is. It's 1.5850. 1.5850 plus 1.5850. And I get an answer of 3.17. So I get log 2, 9 is approximately equal to 3.17. And I'm going to go over here to this log 2/6, and I'm going to do the same thing. I'm going to change my equal sign to an approximate, or at least change it to an approximate, because I rounded that answer off too.